Okay, this is the M1 paper from October 2020. It's question number 5. This is a vectors question, but it's a vectors question that's going to involve velocity and time. Later on, we're going to have a constant acceleration, so that's all our suvat work that we're going to be involved in. And looking at the question, we can see it's a relatively big question. It's worth, 3, 6, 9, 13 marks here, but actually each individual bit is a relatively straightforward and standard vectors question. So let's have a look at it. Let's get started. We're told in the introduction that the velocity is given by this thing here. And part A, they're going to say, can we find the speed when t equals 2? Well, actually, I'm going to underline that to remind myself when I finish this part. Speed is going to be find the velocity, then find the magnitude of the velocity. Don't let them catch you out with that. It's something they do quite often. So we're aware that they might have some little tricks and we'll not fall into any of the traps here. So we've got V is equal to, what was it, 7 minus 5ti and 12t minus 20j. Okay, and then they said at t equals 2. So let's plug that in. What's V going to work out to be? It's going to be 7 minus 10i, and it's going to be 24 minus 20j. So that's minus 3i plus 4j. And as I say, even if I did forget, oh yeah, speed. Speed is the magnitude of the velocity. Tell the examiner that I know that. Speed is equal to magnitude of the velocity. So it's the magnitude of minus 3 squared plus 4 squared. You can do it on the calculator, but I would expect you really to know and to recognize the 3, 4, 5 triangle. So it's going to be 5 meters per second. Don't forget your units in there. That's part A done. Part B, what are they asking us? Find to the nearest degree. Well, again, let's just underline that to remind ourselves at the end. Find to the nearest degree the size of the angle between the direction of motion, okay, between minus 3i plus 4j, and the vector j when t equals 2. Yeah, okay, so again, a relatively standard part here. Let's just do a quick quadrant and show where the vector minus 3i plus 4j is going to be. If we're working out an angle question, always just do a really quick sketch. And I mean really quick. All I want to know is which of these 4 quadrants it's going to be in. And minus 3i plus 4j, minus 3i plus 4j would look like that vector there. And they want to know the angle between that vector and j. Right, I'm just going to change my pen colour for a second to just make it clear. J is that vector just up there, isn't it? So if they want the angle between my velocity and j, they're actually asking for this angle here. Looking at that, using parallel lines, we can say, well, alternate angles there, haven't we? Z angles. That angle there is also theta, which is going to be the same angle. And I can work out that angle just using, got a right angle triangle here, haven't we? Okay, so if I've got that right angle triangle, I can use my right angle trig. Tan theta is going to be opposite over adjacent. So if tan theta is equal to that, theta, tan to the minus 1 of that, and remember, I'll do it straight away, that we said in the question we want to the nearest degree. So 37 degrees is the angle between those two. Right, fantastic. Okay, now we're on to part C and part D, and they talk about using constant acceleration here. So if we're using constant acceleration, that's going to be a suvat question. Find the acceleration in terms of I and J, so part C. If I'm going to be doing a suvat question, what I'm normally hopeful with a suvat question is that they'll give me 4 of the variables being involved, and I'll have 3 of them and be looking for the 4th one. Well, I know I'm looking for A. What else have I got here? Well, I'm going to have to generate some of this stuff myself, actually. What I do know is that when t is equal to 2, the velocity is equal to minus 3I plus 4j. So that's like a final velocity. It's the final velocity from 0 to 2. So I've either got to work out S or I've got to work out U. I'm not going to be working out S. U is easy enough to do then, isn't it? Because if I want to find U, so we're going to do this first. If V was equal to 7 minus 5ti and 12t minus 20j, for U, we're just going to have t equals 0. So U is going to work out to be, if t is 0 there and t is 0, and t is 0 there, it's going to be 7i minus 20j, isn't it? So U is equal to 7i minus 20j. Brilliant. Okay, now I've got that. I've got what I said I always want, which is 1, 2, 3 of the variables, and I'm looking for the fourth one. So now I can just get on and do that as a suvat question. The variables involved this time are U, V, A, and T. So for anybody who's done any work on kinematics, that should not be complicated to see that what we're going to do for this part is just do V equals U plus AT. So V was minus 3i plus 4j. U was 7i minus 20j. T was equal to 2, so plus 2a. Right, okay. All of that bit goes over then, and I'm going to get that 2a is equal to, what's that going to be, minus 10i, and it's going to be plus 24j. Right, so if that's 2a, then a is just half of that, so that's minus 5i plus 12j. And looking at the question, they said, yep, can you just work out A in terms of I and J? And I've done that. Right, on to part D. Part D says, can you find the value of T when P is moving in the direction of minus 5i plus 8j? And again, this is an absolute classic part to a vectors question. This one really does sometimes catch you guys out, so let's just have a focus on this one. Find the value of T when P is moving in the direction of that. So minus 5i plus 8j, if moving in the direction minus 5i plus 8j, what can we say about it? Well, what we can say is that if it's moving in this direction here, minus 5i plus 8, actually let's draw it in the right quadrant, minus 5i plus 8j would look something like that, wouldn't it? Minus 5 and then plus 8. But if my vector is moving in that same direction, then they're parallel to each other. If they're parallel to each other, then they have the same gradient. So if they have the same gradient, then I can say that the gradient of this one is going to be equal to the gradient of my generic one, my 7 minus 5ti plus 22, 12t minus 20j. Well, I'm stumbling over that. Let's make it a bit clearer. Actually, by now doing this. So for the vector minus 5i plus 8j, the gradient is equal to 8 over minus 5. Well, that's the same as the gradient for my v, which is 12t minus 20 over 7 minus 5t. Yeah, just go back and look. Where are we? There's the general form for it. So the gradient of this one is going to be this divided by that. That's going to be the same as 8 divided by minus 5. Okay, they're parallel to each other. They have the same gradient. So if that's true, right, that's easy now. That's just an equation that I need to solve by multiplying everything out and tidying it all up. So if we do that, we get 8 times 7 is 56. 8 times 5 is 40, is equal to minus 60t plus 100, and then just rearrange all that and tidy it up. If you rearrange that and tidy it all up, t works out to be equal to 2.2 seconds and Yep, that's all I was asked for. The value of t doesn't say anything about decimal places or significant figures, so that's that question. Nice little question that, lots of different techniques. Hopefully all of them make sense.